This is lesson 10-4. We're going to start it though with a review of what you did the prior day. So go through and see if you can answer 1 through 5. Pause the video and see what you can do. Alright, are you back? So let's check your answers. The first one you should have gotten 80 degrees. The next one is 40 degrees. 45 is the measure of the length of that line segment. 22.5 is the measure of NT, and then RT is 26.8. Not sure how to do that? That's okay. Let's go through it. Okay, so what they tell us on this is the radius of R is 35. So we know that PR equals 35. We also know that RQ, so radius, yeah, RQ is also 35. Okay, and we also notice that there's a right angle right there, so that means that these are congruent. And then it says the measure of arc LM is 80 degrees, 80. So I'm going to take this 80 and put it right here. But you need to remember that that also is this. So this is 80 degrees right there. So you can put the 80 on the outside, you can put the 80 on the inside. That's LM. The measure of line segment LM is 45, so since this is split by that perpendicular line, that means that this is 22.5 and 22.5. Okay, another thing about this is that this is 35. This is 35. This is 35 right here. And we could do the same thing over here. 35, those are all radii. 35. If that's 80 degrees and these are congruent, then each of these little pieces are 40 degrees. So I just start out writing the little things that I already know about this thing. So notice also that they ask for the measure of arc NQ. Well, the measure of arc NQ is right here. So if the whole thing is 80 degrees because LM is congruent to NO, LM is congruent to NO, so that also means that NO is 45 degrees. So then we're down to finding NT. So NT on this is going to be half of that 45 degrees, because this whole thing is 45 degrees. And then RT on this one, you have to do a little bit of thought on this one. So RT is in the triangle that looks like this. You know, this is 45, this is T, this is R, this is O. We know that this is 40 degrees. We know that this is 35 degrees. And then we're asked to figure out what RT is. Well, RT is over here. It's a leg of this right triangle. Sorry, that's not 35, it's 35. It's the length. So we're going to use our trig functions. 35 is the hypotenuse. X is a leg. It's adjacent. So we're going to use the cosine function. Sorry, my notes had the wrong thing on here. So you're going to have the cosine of 40 degrees. Turn that off. The cosine of 40 degrees equals the adjacent, which is x, over the hypotenuse, which is 35. So RT, or x, is going to equal 35 times the cosine of 40 degrees. So if I do that on my calculator, 35 cosine of 40, I end up with 26.8. I did do it that way. My notes had a different way of solving this. Okay, so that's 26.8 on that one. Make sure that your calculator mode is in degree. If you didn't get that number, if you get a really small number, a really small negative number, watch out for that. Okay, so when you do this one, I want you to visualize ice cream cones. I want you to think about this. We kind of talked about this maybe in your class. I think we did. If you have an ice cream cone, if I draw this as an ice cream cone, in the middle of this is called an inscribed angle. It's an angle that goes all the way across the circle. It's created by two chords. We've talked about vertical angles. I mean, not vertical angles, central angles. So a central angle and the measure of the arc are identical. So this and the measure of that angle are identical to each other. I want you to think about which has more calories in it. Does, and if this looks like an ice cream cone, I consider this to be my ice cream. The ice cream has more calories, so it's bigger. So you're going to learn about a relationship between these two, which is if an angle is inscribed in a circle, meaning that two chords create it, but the vertex is on the circle, the measure of the angle equals 1/2 the measure of its intercepted arc. So this angle right here is 1/2 of whatever this angle is. So if this is, say, 100, then this one is 50. So hence the ice cream cone. More calories in the ice cream than there are in the cone, and how much more? 2 times the calories up here. Alright, so now let's apply this. So if we want to find the measure of angle x, the measure of angle x is this inscribed angle. I know that because it's on the vertex is on the circle. The measure of the arc, that would be this thing, is 86 degrees. So the measure of angle x is 43 degrees. The measure of arc yx, that again is the central angle measure. So here's yx is right here. It's the minor arc. So if this is 52 degrees for the inscribed one, this is 104 degrees. You double it. So for this page, we're going to look at what's really going on here. If the measure of this arc is one number, this angle is considered to be inscribed on that same arc, but it's the inscribed arc. So this arc right here is going to be 1/2 of that arc right there. Then look at the other one. The other one, I changed my color. The one that I'm going to highlight in orange is also an inscribed angle on this same arc. So if this arc is 1/2 of the arc AC, and if the green arc is 1/2 of the arc AC, the measure of the arc AC, then both of these have to be equal to each other. And then look at this one. This is the inscribed angle. It's inscribed on a semicircle. So here's the vertex. The endpoints of the line segments that are not on the vertex tell us where our arc starts and stops. Okay, so this is a semicircle, so this is 180 degrees. So what do you suppose this angle is? If you thought it's half, then you're right. Okay, then we've got this one. We'll talk about that later. So here's some theorems for you. If two inscribed angles of a circle intercept the same arc, which they do on this one, then the angles are congruent. This one, if it intercepts a semicircle, then this is 90 degrees. And then this one, if the quadrilateral is inscribed in a circle, turns out that the opposite angles are supplements of each other. But it has to be inscribed. And it also has to be a quadrilateral. Okay, K and M are also supplementary. So we're going to apply that on 10-4. On the example. So here's our new example. I've got this inscribed angle, this inscribed angle. The endpoints of this one, Q and T, match up with the endpoints of the other one, Q and T. So that means the angle R is congruent to angle S. So we can say that 12x minus 13 equals 9x plus 2. And then you would solve these, and then you would plug in for x into angle R. So to save time, I'm just going to leave it there, but for your work, you have to actually solve and find x. Okay, then we look at this one. This is a diameter. So, knowing that, we know that this has to be 90 degrees. So the sums of the angles in a triangle is 180. Well, 90 degrees of it is already used up. So to set up this one, you would set it up as 90 equals x plus 4 plus 8x minus 4. Because this plus that has to equal 90 degrees, since 90 degrees of the triangle is already used up. Okay, again, you would continue and solve that one. Now let's set up this one. It's a quadrilateral. It's inscribed on the circle. These are opposites. So to set this one up, it would be 180 equals 14x plus 8x plus 4. So these two are supplements of each other. And then you would continue and solve. So the pictures get a little bit more complex, but don't worry about it. You'll be okay. Let's just look and see what we've got. AC is a diameter. So if AC is a diameter, kind of see right here that we've got an inscribed angle. So that must be 90 degrees if that's a diameter. Okay, then it says CD, arc CD, measures 68 degrees. So that means that any angle that's inscribed in there, so I've got CBD has to be 34 degrees. And here's another one inscribed on that. CED also has to be 34 degrees. Okay, so we've got CED done. BDE. BDE is another one that is inscribed, and this time it's inscribed, let me change colors again. BDE is inscribed on this arc right here. Okay, so for this one, BE is 96 degrees. And if we want to find BDE, we're going to look right here. That's an inscribed angle. So the measure of angle BDE is going to be 1/2 of 96. So 1/2 of 96 is 48 degrees. Let me write CED on here. CED was 34 degrees. The measure of arc AD. The measure of arc AD, let me change colors again. Orange. So arc AED, measure of arc AD, sorry. AD is right here. So you have to notice that if I add it with the 68 degree one, we end up matching up the diameter. So the measure of arc AD is going to be 180 degrees minus 68, which is 112 degrees. And did we get ABC? ABC is 90. You're going to have to go to part 2 for the rest of this.